Welcome to Water Supply and Wastewater Engineering class. So today we'll be starting a new unit, that is water storage tank and water supply network. So if you recall, in the last unit we have discussed about water supply plant design layouts and all. So in the before that we have discussed about the different units for the clarification of water. So once water is clarified in the water treatment plant, it is purified, it is all the pollutants present in the water has been removed, then water will be distributed to the household for the further domestic usage. So in this lecture, basically we'll be discussing about the water distribution system, how to design it, how what is the storage tank and all, and how to lay down the pipes. All these things we'll be discussing in details in this lecture. So here water distribution system. So the main purpose of the distribution system is to deliver the water to the consumer with appropriate quality, quantity, and the pressure, right? So already we have purified the water. We have collected the water from the raw water source, and then water has been distributed, water has been carried out to the water treatment plant, and from in there also we have seen the different units present in the water treatment plant, and each unit will remove some portion of the pollutant present in the water, and ultimately water gets clarified. In the last step, if you recall, we have discussed about disinfection is the final step where all the chemical, all the virus, pathogenic viruses and bacteria will be removed using, in this last unit. So once water is purified, then it's time to distribute the water into the entire city. So the main objective for the distribution is we should maintain the quality of the water, right? Already we have purified the water, while distributing, after distribution also almost same quality of water uh, we should transfer to the household of a city or the industry, wherever the water is required. So quantity, quality, and also the pressure is very much important. If water is going very slowly into the household or maybe in the industry, then again it may not serve its purpose. So we have to make sure the quality of the water is good. Quantity means we have seen right in the initial unit lectures where we have seen the variation in the water also, and during some time water demand will be very high, during the some time of day or some time of the year again water demand will be very less. So depending on the quality, quantity, and also the pressure, we have to take care of all these three important parameters while designing the water distribution plant. So now the distribution system is used to describe collectively the facilities used to water supply from its source to the point of usage. So the entire water distribution plant is not only starting from collection of water from the raw water source, and then it will come to water treatment plant, and then the different units it will pass through, and ultimately it will be distributed to the household. So once the final water came here, so from there basically through pipe networks it will go to city, and different portion water will be distributed, something like that shape. So the from collection of water to the raw source to purification and distribution to the household. So the entire process is actually comes under water distribution system, and every from starting to end we have to design perfectly so that we can achieve our objective. It is good quality, quantity, and pressure should be maintained in the system. So now the requirements for of the good distribution system. The water quality should not get deteriorated in the distribution. That is very much important first parameter. So because already we have collected the pollutant water from the surface, and from there we have removed all the pollutant which is present in the water. So again water should not get degraded because of again the distribution system and all. So it should be capable of supplying water at all intended places with sufficient pressure head. So in the entire city, all locations of the city, our water treatment distribution system should supply the water in a sufficient pressure. This is again very much important, because in some areas you will find the water will be coming very slowly. In that case, the people will do some malpractice. They will attach some motor type to collect the more and more water from the distribution system. But again it is illegal, because that's why government has to make sure that the water treatment facilities has to make sure that the water is distributed with a sufficient pressure head. It should be capable of supplying the requisite amount of water during the firefighting. So during the fire time, we have seen earlier also the water demand will be exponentially increased in a short duration of time, but the large quantity of water has to be delivered. So in that case, our distribution system also should take care, about the such emergency situations as well. The layout should be such that no consumer would be without water supply during even during the repair of any section of the, the maintenance is one of the key parameter in the water treatment plan, because but the physical parameters with the pipes and all are actually made up of cast iron or maybe a concrete pipe. So in that case also there will be maintenance will be there every frequently. In that case we have to stop or we have to cut that main line, but we have to design the water treatment plant such that even if during the repairing phase also water should be distributed into the all households. So all the distribution pipes should be preferably laid 1 meter away or above from the sewer pipe. That is again very much important, because we are distributing the clean water. So this should be very far apart from the sewage line, because again if any leakage happens into our main distribution system, then again the pollutant will come into distribute the main purified water. Again this will create problem into the entire system. And it should be fairly watertight. That is very much important. We have seen almost 25 to 30% of the water, treated water will get um, loss because of leakage in the pipe. Water will go out and the leak will be ultimately the water loss is almost 30 to 40%. Can you imagine? It's a huge quantity. So we should design the water treatment plant such that water distribution system such that the losses should be as minimal as possible. Next, the layouts of distribution system means how will you place the pipes of network. So this is the maybe entire city area where we want to distribute the water, and here maybe our water treatment plant, maybe somewhere water is flowing, river is coming here, from there we collected the river, and here you have treated the water. Now from here basically water has to be distributed to the household, right? So entire city and industries we have to distribute it. Now how will you distribute? What are the layouts basically you will follow? So layout is nothing but what are the pattern you will be following, like whether water directly like that water will go, or maybe in some grid manner water will go, or circular manner. What is the layout that we are talking about now? So the distribution pipes are generally laid below the road level, right? Below the road surface. Basically, they will find the distribution pipes are laid down, and as such, their layouts are generally follow the layout of road, is not it? So if the whatever the road follows, when the distribution pipe also follows in the same line. So there are in general four different types of pipe networks you will find. So depending on the usage of, depending on the city condition, depending on quantity of water to be delivered, all this we can choose either any of these four layouts of distribution network. So the first type is the dead end system. Then next one is the grid iron system. The third one is the ring system, and the fourth one is the radial system. So depending on the city, depending on the water demand, we can choose which one can be useful. Again, cost of the distribution supply also will vary. So if you choose some system, in that case it may be cost effective, but again during the emergency time it may not deliver good quantity of water also. So each method or each layout has some pros and cons. So depending on our requirements, you have to choose which layout we will be using. So now we'll be seeing one by one each system in details. So the first type, as I mentioned, is the dead end system. So dead end system is basically useful. You can see this is the type of design system. It is very useful when the cities, old cities, they're already developed cities, roads and all already constructed in a haphazard random manner. In that case, the road also not systematic way. Maybe you will find small narrow roads where wide roads. Right, in that case, we can use dead end or the tree structure, where you can see this M always denotes the main pipe, means this pipe is coming from the main water treatment plant. So M denotes main pipe. So you can see the main pipe is going straight, and then the S don't denotes actually the sub main pipe, and B means the branch pipe, and dot means actually bulbs, cut off bulbs. Okay, this is, you can see, this is our main pipe. From main pipe basically water will go to sub main pipe. So all these are all sub main pipes. As you can see, this dead end means always the end will be dead, right? When the it water will go, and this is the last end. It don't continue here after that. So that's why the method also dead end, and that's why this is more suitable if the city is already developed, an old city we are talking about, because their roads will be already constructed in that city. So whatever road line follows, that only pipeline we have to follow, and then this dead end or tree system we have to use it. So it will also have some advantages as well as disadvantages. What is the advantage? So advantage is, you can see, relatively cheap, because you have to just follow the road line, and very simple dead end technique it is. Dimension, digital determination of discharge, like how much water is going in each pipe, that also can be observed. The pressure easier due to less number of valves. So here valve will be less. Valve means, why we provide valves? Cutoff valves means, basically, if you want to restrict the water to flow this pipe, so then we call it valves. Right? For example, and some leakage happened here or somewhere here, so immediately what they will do, they will immediately close this valve, so that no water will go here. The water will only distribute to entire remaining part. Water won't go here, so because you close this valve, so the distribution will be, so the repairing will be happening, right? So valve is very much important in the dead end system, and if you close the valve, so easily you can maintain the pressure in each signals, each lines, each networks, right? Now the disadvantage of dead end system is due to the many dead ends, right? What segregation of water occurs in the pipe, right? Because all ends are dead end, right? So because of that, water, say, stagnation will be happening inside the pipe, and which may again create some problem in the water quality. So otherwise, the dead end system is good, but again the problem with dead end system is that, for example, here you want to distribute the water, but if any fault happened here, then you have to close the entire segment, so the water won't be distributed to the entire area until and unless the repair is happening. So there is no alternative way to distribute the water. That is again the problem with that is a dead end system. Okay, but here the advantage is, as I mentioned, so here very easily you can divert the water from one end to another end. So now the next layout system is the grid iron system. So here you can see water is flowing in a gridded manner. So this is the main pipe. You can see this M is the main pipe, will go this one, and from there sub main pipe will be going from the main pipe. And see, these are all branch pipe also will be there. So B is actually branch pipe. So and cut-off valves, so many cut-off valves you can see here. So it is basically suitable for the cities with rectangular layout. So where the new city, if you are planning, normally we go with rectangular or a circular pattern. So in that case, this is very much useful. So all the new cities or then developing new areas, you will find will follow the grid pattern. So in that case, this type of technique will be useful in that areas. So the advantage is water is keep in circulation. So if you see, all pipes are connected, is not it? So water is in circulation. So it is unlike dead end system where the water is stagnant, but here the water will be simply circulating from the entire network. So this is again advantage. So in case of breakdown in some areas, so now if you see, if any breakdown happen in one portion, then again you can distribute the water. You can open another valve, and then water will be distributed here also. For example, something happened in this pipe here, so it is cut out, right? You will just close this valve, the water cannot come here, but you can open this valve, then water will go here, and like that it will go, and it can be distributed this end also. So that is the advantage with the grid iron system also. Now, the disadvantage with this type of pattern is that exact calculation of size of pipe is not possible, because here so many valves are there. See, so many valves in each location. Some valve will be closed, some valve will be open. So it is sometimes, that's why it is difficult for the exact calculation. What is the size of pipe is working, and what is the pressure in each. So sometimes it will be difficult. So now the third one is the ring system. So in the ring system, what is the difference? This also looks like grid pattern, but the here only difference is that here main will be going periphery of this entire network. Unlike earlier, the main pipe was going middle, and the branch pipe was going parallelly and perpendicular to the line. But here in the ring system, basically the main pipe will go periphery to this network, and from there sub main pipe will go and enter to the city. So the main pipe is laid all along the peripheral roads, and the sub-main pipes are out from the main pipes, right? That the system is also follows grid iron, whatever we discussed earlier. So the determination of size pipes here, it will be easier, because any water is flowing in the same mm, same way. And here the advantage with this ring system is that, at any point, if you see, there are two minimum 2 ways, at least 2 ways you can distribute the water, right? So some portion, if any valve is closed because of repairing purpose or anything, still you can distribute the water in some other direction. For example, if this valve is closed, then still water will distribute. If you have to open this valve, then water will come here and it can be distributed in this area also. So this is the advantage with the ring system. Now the next type or the last type of system is the radial system. Again, this is very much important here and in very rural areas, right? And the villages basically they use the radial systems. In the radial system, what they will do, the entire city area will be there, right? There are some main a few grid points. It will be identified, and there the overhead tanks will be constructed. So the overhead tank will distribute the water into the nearby areas. That's why the system is radial system, right? So through pump, basically we keep the water in the overhead tank, and then water will be distributed in the different pipes, okay? And I mean in a radial manner. So the area will be divided into different zones. The water is pumped into the distribution reservoirs. So water will be kept stored here. Then the by gravity itself, water will flow through the radial direction, right? Because normally, 30-meter 40-meter height, we keep the water for no, in a water tank. So the advantage is it gives the quick service, right? Immediately you open the valve, water will simply go by the gravity itself. So the calculation of pipe size also will be very easy and a very systematic way you can do that. So the main branch, if you see this is it is follows, and from the main branch basically we pump the water and we store it into the water overhead tank, and then the water will distribute it to the radially into the different sections. So now you have seen, depending on again the criteria, depending upon the quality of water, depending upon the city's development, depending on the how much quantity of water is required, we can choose either any of the four different layouts. So now the next one is the distribution reservoir. So distribution reservoir is also called the service reservoir, right? So we have to so the water treatment process in a plant will be continuous, right? But you can see that demand is also not continuous. So morning time demand will gradually increase. Early morning, everyone takes bath, demand will be high. Then again in the afternoon time demand will be less. Again people coming to evening time, again the demand will be increased. Again night time demand will be less. So like that pattern it follows, is not it? But the water treatment in a plant is almost constant every time. It's same quantity of water will be purified. So the excess water will be stored somewhere, right? That's what we call a distribution reservoir. So some reservoirs are made where the water is will be stored for the distribution purpose. So distribution purpose is also called service reservoir at the storage reservoir, which stores the treated water, right, for the supplying water during the emergencies such as during fire, right, and the repair all these things. Suddenly you need water, right? For example, you need to repair the entire water treatment plant. So for that purpose time, if you have a distribution reservoir where we keep the water stored for some time, right? So in that case, that will be again helpful. So during this, from this distribution reservoir, we can distribute the water into the household. So the function of distribution reservoir is basically to absorb the hourly variations in demand. As I mentioned, right, hourly variation will be there. Morning will be more water required, evening time again more water will be required. So that can be taken care by the distribution reservoir. Next one is to maintain the constant pressure head in the distribution main. So distribution main, you have to maintain the proper pressure head, right? So for that also the fixed quantity of water always should be maintained. The water stored can be supplied during the emergency purposes. Also we need the distribution reservoir. So the distribution reservoir location and the height of distribution reservoir, and it should be, so distribution reservoir should be located as close as possible at center of the demand. For example, during where is the residential area, so near to the residential area you construct the distribution reservoir. So distribution reservoir can be constructed on a ground or maybe in overhead tank. We will see different types of reservoir later. So the water level in the reservoir must be at the sufficient elevation to permit the gravity flow, yeah, at adequate pressure, right? So if that's what we discussed about overhead tanks. So their water will flow by gravity, right? So that, so location we have to choose such that where the demand is there nearby only we have to construct the distribution reservoir. Now the type of reservoir you will find, the underground reservoir will be there, then small ground level reservoir will be there, large ground level reservoir will be there, and the overhead tanks will be there. So basically depending on our requirements, again we can choose which type of reservoir we want for our distribution. So the next is the storage capacity of the distribution system. So how much storage capacity will you keep in the distribution system? So see, we are sequentially moving. Initially, we discussed the different layouts like pipe layouts and all. Then we are discussing about distribution system reservoir, because we have to keep the water stored for some times, right? So the how much quantity of water we can store it, so that depends on the balancing storage. So we have to plot this mass curve method. We'll be discussing in the next slide, that is mass curve method in details. But basically we have to plot a graph where have with the demand and the production, how much it is happening, and with this balancing storage we can find it out how much is the water quantity has to be stored for in a reservoir, the quantity of water required to be stored in the reservoir for the equalizing or balancing the fluctuation of demand, right? Sometimes morning time demand will be more, evening time demand will be less. So to take care of this fluctuation, basically balancing storage system is required. Now next is breakdown storage and the fire storage. So if you combine all the, you do the calculation for all these three separately, and whatever the final value, that will be the dimension of the storage, reservoir storage. So through balancing storage you get some value that that much quantity of water minimum should be stored. Next one is the breakdown storage, like due to emergency situation. So sometimes that some failure of a pump or electricity, or maybe water treatment in some portions are majorly failure. So in that case also, from the reservoir we can distribute for at least for few hours, we can distribute the water from the reservoir directly. So that is breakdown storage, we call it. And the last one is the fire storage. During the fire breakdown we need large quantity of water, right, in a small duration time. So that also should be stored in a reservoir. So if you add all these three, that we will get it how much is the total reservoir storage is required for the entire city. So as I mentioned in the last slide, that we the balance thing we can get it from the mass curve method. So this is the mass curve method. You can plot it how much demand is there, and how much is the water supply is there. So this is the supply, because it is constant, right? At all 24 hours constant quantity of water will be clarified. So this is purified. So this is the black line, whereas this one is the demand. So sometimes demand will be very high. Whatever is produced, that is more than demand, and demand will be more, sometimes the demand will be very less. So to balance all this, how much is the surplus and how much is the deficit, by considering both, basically we finalize how much is the balance reservoir is required. Okay, so in this lecture what we have discussed is the entire distribution system. So once water is purified, now how we can distribute the water efficiently to the household. We have seen the different layouts depending on different conditions, depending on the city development, depending on how much quantity of water, how much water pressure has to be maintained. Depending on all these parameters, basically we can choose what is the different layout of distribution system. Then we have discussed about the reservoirs. So reservoirs, we have to store the water, purified water, for some time to take care about fire demand or maybe some fluctuation in the water demand. So that also how to finalize what is the dimension, where to keep it. All these things we have discussed in this. So this concludes this lecture.